Your lawn isn't wet from rain. It's wet from something the grass itself is doing. Every morning, millions of people step onto grass covered in water. Most assume it rained overnight. But here's the thing, the ground is bone dry, the sky was clear, and yet the blades glisten. So where does this water actually come from? The answer isn't in the clouds. It's in the soil beneath your feet. Plants are living pumps. Roots draw water from the soil, sometimes from surprisingly deep down where it stays cool and stable. But plants don't just store this water, they move it. Constantly, water travels up through the stem, through the leaves, and then something remarkable happens. It escapes into the air. Scientists call this process transpiration. It sounds clinical, but it's almost like sweating. The plant opens tiny pores on its leaves, called stomata, and releases water vapor directly into the surrounding air. This isn't waste, it's necessary. The evaporating water cools the plant, moves nutrients around, and helps the leaves stay firm and healthy. But here's where the mystery deepens. Why do we see liquid water on the grass in the morning if the plant is releasing vapor? The answer lies in temperature. During the day, the air is warm. Warm air can hold a lot of water vapor, it just floats there, invisible. But when the sun sets, everything cools down. The grass cools. The soil cools. The air itself gets colder, and cold air can't hold as much moisture. Something has to give. This is called the dew point. It's the exact temperature at which air becomes saturated, completely full of water vapor. When the temperature drops below this threshold, the vapor can't stay invisible anymore. It has to condense. It transforms from a gas into tiny liquid droplets. And where does it condense first? On the coolest surfaces around. Grass blades, spider webs, car windows, and parked cars. Grass is particularly good at collecting dew. Each blade is thin and exposed to the air. It radiates heat quickly as night falls, cooling faster than the surrounding soil. This makes it an ideal landing pad for water molecules. By 4 or 5 in the morning, when temperatures have dropped their lowest, the grass is absolutely drenched. But the water didn't fall from the sky. It rose from the ground and fell back down. Now here's a detail that changes everything. Not all dew comes from transpiration. Some of it comes directly from the soil. Water in the ground also evaporates, especially when the soil is moist and warm. This water vapor rises up into the air above the grass. When night falls and temperatures drop, this vapor condenses too. So dew is actually a mixture, some from the plant, some from the earth itself. The amount of dew you see depends on several things. Humidity matters. If the air is already saturated, more dew forms. Temperature matters. The bigger the drop between day and night, the more condensation occurs. Even the time of year plays a role. Spring and fall typically produce the heaviest dew because nights cool dramatically while plants are still actively transpiring. Geography matters too. Coastal areas often see more dew because ocean air holds more moisture. Valleys collect dew more than hilltops because cool air sinks and settles low. Even a lawn surrounded by trees will be wetter than an exposed field because trees trap moisture and create a more humid microclimate. Dew isn't random. It follows the laws of physics with precision. There's something almost poetic about this process. The grass actively gives water to the air during the day. The air holds it invisibly. And then when the world cools down, that same water returns to the grass as jewel-like droplets. It's a daily cycle of exchange, a conversation between the plant and the atmosphere. Nothing is wasted. Everything moves. But dew isn't just beautiful. It's also functional. For insects and small animals, dew is a water source. Plants use the moisture to absorb nutrients more easily. Fungi and microorganisms in the soil thrive when dew moistens the surface. In dry climates, dew can be the difference between survival and drought. It's a hidden lifeline that most of us walk through without noticing. Humans have known about dew for thousands of years. Ancient farmers used it as a sign. Heavy dew meant good growing conditions ahead. In arid regions, people have actually designed systems to collect dew, harvesting water from the air itself. It's a technology that's gaining attention again as water becomes scarcer. We're learning to do what the grass has always known how to do, pull moisture from thin air. So the next time you walk across a dewy lawn in the morning, you're witnessing something far more intricate than a simple weather event. You're seeing the invisible made visible. You're watching the exchange of water between earth and sky. You're standing in a moment where physics, biology, and chemistry all intersect. The grass isn't wet because it rained. The grass is wet because the world is breathing. And now you know the answer to that question that probably never occurred to you until this morning. Where does morning dew actually come from? It comes from the plant. It comes from the soil. It comes from the air itself. It's a creation of temperature, humidity, and time. It's physics turned into water droplets. It's nature's quiet miracle happening in every lawn, every garden, every field on Earth, every single night. Subscribe so you don't miss the physics hiding in plain sight. There's a new everyday mystery waiting next week.